stack data structure resembles what? It resembles this. This is a stack of notebooks. Okay, means one after the other, and you can only take up if you want to take one book, you can only take up from top. Okay, if you want to take this book, then first you have to take all the book above it, then only you can take this book. Okay, and if you want to add any book, then it will only be added. If you want to add further onto this, let's say if your stack is this much, and if you want to add any more elements, then you can only add it at the top. Okay, so this is what a stack data structure is. Like push and pop operation of a stack is implemented in array or linked list in such a way that that you can only, push means inserting an element, you can only insert it at the top. Okay, and you can, pop is also implemented in such a way that you can only take the element of the top, take the topmost element. So stack is a data structure where insertion and deletion happens from one side, represented as top, making it like LIFO, last in, first out. So if I start piling books, this is my first element, then I add another element, this is called push. Another push, another push, another push. Okay, now what is the last element that gets in there? The first element, means the topmost element is the last element. So when you want to pop elements, the last element that got inserted will be popped out. That's why it is called last in, first out. So in case of array-based implementation, you must know the size of the stack beforehand. So maximum size of the stack must first be defined. That is basically when you are defining an array. Okay, let's say if this is my stack A, so while you are initializing it, you must know that it's of length n. Now this array will be viewed as a stack. That means you are just going to call push and pop, and internally they are implemented in a manner that push means the topmost element. Let's say your elements right now is 2, 3, 6, 8, and rest of the stack is still empty. Then this is the top element. Okay, push operation will increase the value of top by 1, and now top is pointing to this, and let's say your new element was 12, and that 12 is added to this stack. Okay, and if you want to pop element, then this top is going to be decremented by 1. Now top is this, and this 12 is out. Okay, so as you can see, push, if top is not equal to n minus 1, push means you want to add an element to the stack. If top is not equal to n minus 1, means that top is not this, top is not pointing to this. If top points to this element, means what? It means all the elements are full, because to begin with your stack is empty. At that time your top value is -1, and as you keep on inserting an element, your top value will increase by 1, and it will always point to the last element, because we are taking the, as you can see, insertion deletion from one side. Okay, so we are taking the last element, means the end side, to be the topmost element. Okay, so if top is not equal to n minus 1, means that if stack is not full, then a plus plus top means you first increase the, this is pre-increment, you first increase the value of top. So if top initially was here, let's say top initially was here, plus plus top means first you increment the top. Now top is pointing to this. Okay, not pointing to this means the index value is 4, top is equal to 4, means top is not a pointer, top is a index value. Okay, so plus plus top means now top is equal to index of this cell, and then the value of that cell is x because that's what we want to push. Okay. But if this is not satisfied, if this gives false, it means top was equal to n minus 1 and means that the stack was full. So print stack is already full. Similarly, when it comes to pop operation, if top is equal to minus 1 means that all the elements are, there are no elements in it. So what to pop? Stack is empty. To begin with, if top is equal to minus 1, top minus 1 means stack is empty. Top minus 1 means stack is empty. So if you cannot perform pop operation when the stack is empty. So if top is minus 1, then the stack is empty. And then, okay, 1 minute. And then you return it. Okay, then you return it. Means I cannot perform this if it was empty. So I have to return from it. If top is equal to minus 1, then you return. Otherwise, if this if condition is not true, means stack has some elements. Now you take that element in your temp. Okay, sorry. This free temp should not be here, should on the linked list side. Because this is not a node. Temp is not a node. Okay. Temp is a cell in the array. So in your temp you get the value of the topmost element and then that's it. Now what will happen? This is your, now this is pointing to your top and you can just return temp to know what is the topmost element. Now look at the linked list implementation of array. So in linked list, push and pop takes place from beginning of the linked list at the front. Okay, that is, push means you are adding node at front and pop is removing first node. So if this is your linked list, then push and pop takes place from beginning. So basically what your head was pointing to, I will call it as top. Top is pointing to the topmost element. Okay. So push means adding an element to the top, means adding to the front, adding one node to the front. Pop means removing the first node. So I will, this top will, this will be freed and this top will be pointing to this. Okay. So as you see that it's in case of stack, insertion deletion happens from one side and we chose that side to be the front side and not the end side. We could have very well said that this is the topmost element. This is the what you say. This is the place from which you will add or you will remove. But then the order of the time complexity will be order of n because we know that insertion and deletion. So insertion and deletion at the end is order of n and at the front is order of 1. That's why we choose the first element, the front element of the linked list to be the top element. Okay. And how to insert at the first element means the code of it we have seen in the linked list. Thank you very much.